So we're going to work on solving multi-step inequalities using the same steps as we did with equations, with the exception of two things. Do you remember what those two things are? One, when do you have to flip that inequality symbol? When you multiply or divide, and for us we're just multiplying since we work with multiplying reciprocals. When you multiply or divide both sides by what? By a negative. And what's the other thing that we need to do that's a little different than what we were doing with equations? You're going to be graphing the solution, right? That's my abbreviation for solution. Okay, so let's start with this two-step inequality as a review. Go ahead and solve this inequality and graph it. You should end up with q is less than -6. Notice that we do not flip the inequality in this problem because we multiplied both sides by a positive number. So it doesn't matter that the number we added by was negative. It doesn't matter that the number on the right side of our inequality is negative. None of that matters. All that matters is that reciprocal. Was that reciprocal negative? Nope. So we did not multiply both sides by a negative, so we leave the inequality as less than. And we're going to graph this with an open circle because there's no equals to in the symbol, and then the arrows should go towards smaller numbers since all the solutions are less than -6. So I want to stop now and explain a couple things about inequalities. First, I'd like to talk about checking inequalities. So any number that's less than -6, not including -6, should make the original inequality a true statement. So if I wanted to, I could pick something easy like q. Is -5 less than -6? Nope. Easy mistake, but it's not. It's actually bigger than. So we need to go with something smaller than -6. So let's go with the next smallest number, which is -7. So back in the original inequality, I'm going to plug in -7 in the place of q and see what happens. We end up with -21 plus 5 is less than -13. So -21 plus 5 is -16, and -16 is less than -13. That's a true statement, right? Well, we've proven that -7 will work, but there's lots of other numbers we could check with, and the other thing is, if q is less than or equal to -6, we wouldn't be checking to see if -6 works. In other words, doing a check step is kind of a imperfect way to check with inequalities. So what I usually do is I let the variable equal whatever my actual solution is, even if it doesn't have an equals to with it. So in this case, I'd let q equal -6, and I'm just going to treat this like an equation and see how it turns out. So instead of as an inequality, I'm going to check it as an equation and see what happens. I get -18 plus 5 equals -13. -13 equals -13, so that's true. So if you treat it as an equation and substitute in the answer you actually get and it works, then your answer is correct, but you have not checked the inequality. You don't know for sure that your inequality symbol is correct. So just keep that in mind and be careful with flipping that inequality if you multiply both sides by a negative. The other thing I wanted to mention is that sometimes when you're solving, you might end up having an inequality like this. If you don't put the variable on the left-hand side and the inequality is flipped around, then you'll end up with an answer like -6 is greater than q, which means the same thing as q is less than -6. Well, I want to show you a little pattern that happens. Whenever you have the variable on the left-hand side, your arrow on your number line will point in the direction of your inequality. So for example, here we have q is less than -6, so less than, the arrow is going to point towards the left. Greater than, the arrow points towards the right. Well, this only works if your variable is on the left-hand side. So that's one of the reasons why I like to have my variable on the left-hand side. It just helps me to double check that I have my arrow pointing the right way when I look at the picture. Go ahead and try this next inequality. Remember to change division to multiplication. In this problem I end up with r is greater than or equal to negative 42, and so therefore my circle is a closed circle since there's an equals to in the inequality, and my arrow is going to point in the positive direction since it's greater than, and notice again that the inequality is pointing in the positive direction as well since my variable's on the left hand side. One thing I want to mention to you is that when you flip the sides around, so when I brought this side over to the left and I brought the right side or the left side over to the right, I had to flip my inequality to make sure that the greater than side was still facing the 16r plus negative 5. So make sure that you flip the inequality if you flip the sides around as well. The other thing you want to make sure you're watching is that whatever you multiply both sides by, if it's negative, you flip the inequality. In this case it was not, so we kept the inequality facing the same way. And I did a check step over to the side, and negative 42 works, so I know that my answer negative 42 is correct. I don't know for sure that my inequality symbol is correct without double checking my work. In this next example, you're going to apply the distributive property and solve. Go ahead and complete this problem. In this problem, I went ahead and used my distributive property and saw that 1/4 would go into 25 times, and 1/4 times negative x is negative 1/4 x. Then I added negative 5 to both sides, multiplied both sides by my reciprocal, which is a negative number. Therefore, I had to flip my inequality on my last step. So I end up with x is greater than negative 4. So I'm going to have an open circle on negative 4, and the arrow is going to point in the greater than direction, just like my inequality does since my variable is on the left hand side. I show you my check steps over to the side where I substitute negative 4 in the place of x back in my original inequality before I change subtraction to addition. And I end up with 6 equals 6, so I know at least my number is correct. Now here's an inequality that has variables on both sides. Go ahead and give this one a try. So here I am showing you my steps for solving this inequality. It's pretty straightforward, except you do have to work with fractions a little bit. So when I end up adding 7/8 a to 3/4 a over here, I came over to the side and completed an addition problem with fractions and getting a common denominator. I recommend that you write those steps out so that you don't make careless mistakes. Again, when we multiply both sides, we need to double check if we're multiplying by a negative. We're not, so we keep the inequality less than or equal to. And I want you to notice when I add 3/4 plus 7/8 and I get 13/8, I leave that improper because we're dealing with multiplication at this point with 13/8 times a. Let's go ahead and leave that improper because we're going to just multiply by the reciprocal, so we don't want a mixed number. So then I get the answer a equals negative 40 over 13. I am going to go ahead and change that to a mixed number so I can place it on my number line as if I had to count over on my number line. Since it's less than or equal to, we're going to have a closed circle and our arrow points in the negative direction and my variable is on the left. So I know that all the solutions are smaller than negative 3 and 1/13, so the arrow goes towards the left. Now I did a check step for this one because I want to illustrate a point to you. So the check step is pretty daunting because of all the fractions. It's not impossible, but I want you to notice how many steps are involved. First, we have the multiplying of fractions where we have to cross cancel. And by the way, I kept the answer as the improper version of the answer since I knew I was going to be multiplying when I substituted them in. And once I simplify the multiplication, I still have these fractions I have to deal with on both sides, and now I'm adding. So since I'm adding, I'm going to change the fractions to mixed numbers. And now I have to add a positive and a negative over here on the left hand side, which I did over to the side to show you borrowing. And I do end up with 7 and 9/13 equals 7 and 9/13, so my answer is right. I want to illustrate two things to you here. One, you can check problems that have fractions in them. Both equations and inequalities. And two, I wouldn't waste your time doing that on a test. I would go for all the other problems that are not going to take you a long time to check them, unless you just have lots of time left over at the end of a test. But usually you will not, so I recommend that you check the problems that are not going to take you a long time to check. Again, here are the steps to this last problem. And here are the check steps. You do need to know how to do these check steps, by the way. So be prepared in case I ask you to show me check steps and give you time to do them. Just don't take time to do check steps like this if you don't have time on a test. That's the last thing you want to do with something this complicated.